Welcome to the Make course. I'm Rudi Schlaf, a professor at the Department of Electrical Engineering at the University of South Florida. This video is about bolting together two parts with an alignment feature. And so I'm discussing here how to consider the 3D printing process already when designing parts. And I'll discuss how to split up parts into printable components. And I'm discussing how to use alignment features and bolts for combining such components. Let's first make a part that one cannot print without supports. And so it doesn't take much for a part that one cannot print it. A very simple example is this. So let's make this 40 and this here 15 millimeters, and let's extrude it. 10 millimeters is good. And now put another block on top here. So let's first project the top of this block. And now let's make a new rectangle. And oh, I forgot to give it dimensions. Let's make this the same. So 15 and 40. And let's align it that it's symmetrical. And for that we need to make a driven dimension here and a driven dimension here. And now we can give this here some dimensions. So this one here we want to be this dimension minus this dimension divided by 2. And you see now it's centered. And we can do the same for this dimension. So, and here of course we want to do this dimension minus this one, and then divide by 2. And now you see it's exactly in the center of that bottom block. So let's extrude this one, and we have a beautiful part that's probably pretty useless, but no matter how you turn it, you cannot print this without supports, right? If you put it down here on this surface on the printer build plate, then you would have to put supports here. Or if you would print it like this, then you would have to put supports under this surface. So this is a very simple part, but it is virtually unprintable without supports. And in my opinion, supports are really the very last resort if nothing else goes, because it always yields a very ugly surface. Imagine if you would have the supports here, you would have to break them off and then sand the surface and paint it and whatnot in order to make it look good. So that's pretty messy. So let's see how we can do better. And doing better is of course splitting this part up into two parts that we can print separately and then bolt together or glue together or something like that. So here in this video I want to show you how to make two parts that you can bolt together with an alignment feature and a bolt, and you will see that this is a very neat process to get a structure like this here going from a 3D printer. So the first step is to make this into two solids. You see here now we have only one solid, which is the entire structure, and so it's very easy to make this into two. I just reopen here that second extrusion feature, and I tell it here to make a new solid out of it, and I say okay, and so now we have two solids, one up here and this one down here. The next step is to put in an alignment feature and then a bolt. And so let me start by making a sketch here on this surface, and now let's make an alignment feature. I like grooves that have a triangular cross section. They can be printed very nicely, and they also yield a very precise fit usually. So the first step is we need to project the geometry so we can put the groove into the right position. So let's just select this edge here and these two. So that gives us a reference frame for our triangle. And why did I do that? And so here, let's select line, and now let's put here a triangle. I like them with a 5mm base, and then with 45-degree angles. So 45-degree angles, they print very nicely in virtually any orientation on most printers. And that pretty much defines our triangle, and now we need to put it in a good location here along this contact area between the two blocks. And I say let's try here 2mm is always a pretty good distance for features, because that allows the printer to change from one mode into the other to make this groove here. So 2mm is a pretty good number, but I'm pretty sure 1mm would work here too. Okay, so now we have this triangle here, and we can extrude it into this block down here. So let's select cut, and we want to extrude over to the other side here. So we use the 2 feature here, and that makes us the cut over onto the other side. Okay, now we have this block here with this groove, and of course the next step is to put the corresponding feature onto the top block here. And we start out again with a sketch. So now we could put the sketch here, or we can put the sketch here. I think it's practical if we put it here. So for this, the first step is to project that groove that we just made. So I select this edge here and this. And you notice I always turn my model a little bit into a perspective view so I can select the edges properly. If it were completely flat, then you may accidentally select the entire plane here or the edge on the opposite end, and in more complicated models this can create problems later on when you go back and change things. So it's always good to exactly select the corner or edge or point that you really want to project. So okay, now here we have this triangle projected, and now we can make a, oh no, we need to of course also project this here, the bottom plane of the block on top, because we want to connect that alignment feature that fits in here of course to this block. So we need to be exactly on the surface with the feature. Okay, so now we need to make a triangle that fits into this groove, and so for this here we can view and slice graphic, and now it's good to really do this in the forward view. And go back to sketch and select the line and turn off the, and so now here we make a triangle that is a little bit smaller than the groove that we just defined. Okay, that's our triangle. And so what has worked for me in the past is to make these gaps here 0.2 millimeters. But that depends a little bit on the printer that you're using and how tight things need to be at the end. But 0.2 is a pretty good starting point. I'm pretty sure that 0.15 or 0.25 would also work fairly well. Okay, now we have this triangle that fits into our groove, and now it's time to extrude it, and we want to go again 2, and so I select now the opposite surface here, so you see it here, it shows you where it's going. But the problem at this point is that this part now, this addition would be part of this body down here because it's marked red. But of course we want to have it up here, so for this we can select solids here and then select the body up here. Now you see the triangle, the feature is now associated with that solid up here, solid number 2. And we can say OK. And now we have basically 2 blocks with an alignment feature. So let me turn off, or actually we can also use here the half section view and go through here. And so you see here now how this top feature fits nicely into the bottom feature, and it goes all the way through. Okay. We can also see this by turning off this feature here. So now you see that you have this alignment feature on this groove. Okay, the final point is, the final task here is to make a feature that we can put a bolt through these 2 parts. And that is very easy. So let me turn this on again here, visibility on. And well, let's put the bolt here from the top. And so let's make a new sketch on top. Placing a bolt always starts out with putting a point, but first of course we need again to project geometry, and because we don't want to drill through our alignment feature now, it's good to project the alignment feature. It's turned off. So here let's select okay, this here should do it. And now you see here this, so our alignment feature is over here, so we want to place the bolt here. For placing the bolt, first we need to place a point, and that point of course needs to be properly constrained. So let's make a driven dimension, and we want to have it of course here in the center of that bottom brick. And now we can place it here at this dimension divided by 2, so it's in the center. And my bolt will have a it's an M3 bolt with a about 7 millimeter diameter head, so it's often useful to put a circle. Oh, it didn't catch on here as construction feature. So to make a construction feature a circle that indicates how big that bolt head is, so you get an idea whether you get too close here to the edge, which may then be troublesome when you print this. And so now we can define the lateral position of that bolt here. And so the next concern is of course the diameter of the bolt hole. So let's make another construction circle here. So the bolt hole, I usually drill at 3.8 millimeters. 3.7 actually works also very well, so let's make this 3.7. It's a little tighter. And this bolt hole of course now should not touch our alignment feature because it will go all the way through. So I'm using this here now to position the bolt. So we can here, oh, I should have gone differently about this. So let's select this and then this here. And see, I move the mouse now and it switches the cursor. And what we want here is this type of dimension, which allows us to define the distance here between the bolt hole edge and the alignment feature edge. And so I'm going to give this here 1 millimeter. And now it is time to place the bolt. So the bolt is made by using the hole feature, and since there's only one point, it automatically selected it. So it always looks for points here, this hole tool. And here I want to use a countersunk M3 bolt, which I very frequently use. This is why this here is already at 3.7 millimeters, and I have a head here of 7.5. So 7 or 7.5 is usually pretty good. I like these bolts because they have that 90 degrees feature here for the head. Again, this prints very nicely in pretty much any orientation, and also these bolts look very nice because they go completely flush with the surface of the part. And so the only question now we still have to answer to this feature is how deep should this hole be? And of course we want to drill through all the way to the other end. And for that, let's select the surface down here. So we can select surface. So I select, this is already was pre-selected, so you could just select the distance here. You could go through everything, which we could have done here too, and you can select a feature down to which you want to drill the hole. So let's do this here. And why is this not working? Let's try this again. So now it's working. Okay. So now it has drilled the hole, or is drilling the hole all the way through. And we still need to select this body here. At this point it would only make the hole through the top part because that is marked, so we can select here this one too. So now it goes through everything. So let's see how this is working. Okay, so now we have a hole, and look how beautiful it already made that countersunk feature for the bolt head. So this is a very nice tool. You can make a bolt with one feature. So now of course this bolt needs to screw into something, and so I propose we use a standard M3 hexagonal nut, and for that we need to make a recess here so that it's also flush at the bottom. And for that of course we need to make a sketch again. So sketch here, and again let's turn this a little bit so we can select exactly the end of this hole. Let's project the geometry with a construction line. So this gives us the center for our hexagon. And now we select here polygon, which is preset to 6 because I usually make hexagons. And now we can make a hexagon here. And in this case, the hexagon needs to be constrained, and because it's closest to this edge, I'm going to make it parallel up here so that we have a maximum a distance between the edge and the polygon. And a good dimension for a M3 nut here is 5.7 or 6 or something like that. Let's try 5.7 millimeters. And so this is the shape of our cavity for the M3 nut that we want to put down here. And so now all we have to do is to extrude this as a cut, and I think usually a 3 millimeter cut is pretty good for this. And so now you see here we have a nice recess for a nut, and up here the bolt head. And now we're almost done. We can print these features now and print these two bars and see how things fit. But before we print it, one more thing. We need to decide on what surface each of these bars will be printed. And here we can now choose this surface or this one, Well, we can actually, this would almost print in any orientation now, but it is good for holes. If they're print vertically, that yields the most round and precise holes. If you print them horizontally, then the holes will be a little bit oval because the printer inadvertently will mess up the top here because it has to kind of fight gravitation a little bit. And so I decide now to print it in this orientation, I think, because this triangle here, this triangular shape, can be printed upside down fairly well, while this here would be challenging because we have here some flat areas. Of course, you could help it by putting a chamfer or a fillet in here to round this off a little bit, but here we don't have to. We can simply print it in this orientation. So I'm selecting this surface here to be connecting to the print plate on the printer, and that means that we need to put a fillet on here. Typically a 1mm fillet is pretty good, because the first layer that's printed is always a little bit squashed, and that means that it kind of spills out a little, and by putting a fillet here you can counteract that. And so let's just go around here and make these 1mm fillets. We don't need to do it here, I think, but let's do it here, because otherwise the bolt may be difficult to get through here. Okay, so apply, and this here we can export now for printing. So for this we simply go here to export and then CAD format, and make sure it's a STL file, and this here is solid number 1. This is already the second time that I do it, so I have these files here already, so let me just overwrite this here. And so this is now saved for printing, and let's get the other one. The ground rule for saving parts for printing is to just make them visible on the screen and then save them as the STL file. So essentially you always get in the STL file what's visible on the screen. And here now we need to select again what side we print this on, but here of course it's a very easy choice because this here could never be the printer surface, the bottom plane of the part, because we have that feature sticking out here. So obviously we have to print it on this side, from this side, and that's why I'm placing my 1mm fillet around here. One can select a loop feature, then here. And usually these countersunk bolt heads, they don't need the fillet around them when you print them upside down, so we can just do with this here. And so now this part is ready for being printed too. So let's go here into export and CAD format, and now this is solid 2, and yes, I want to replace it. Okay, let me go print these two parts and I'll be back. Here you see the two parts. It took about 50 minutes to print them. The alignment features came out fairly well. Let's have a closer look. Here you see the recesses for the nut and the bolt head. And so the bolt head goes in flush, and the alignment features fit well together. So let's put in the nut. It's very nice to put in bolts when you have the nut in a recess, because you don't need to hold the nut in place. You can just tighten it and that's it. And so you see a very nice and clean connection between the two parts, and it's pretty strong, so there is nothing wiggling. So that's how it should be. Okay, that's the end of my video. Now you know how to bolt together two parts using an alignment feature. Thanks for watching.